Beyond our solar system lies a distance of just 4.24 light-years. Yet across that seemingly small stretch of cosmic emptiness, something remarkable has emerged. Astronomers have detected a faint, unusual illumination on Proxima b, a world once dismissed as hostile, barren, and incapable of nurturing life. But now, the James Webb Space Telescope has shifted the narrative forever. It has captured the clearest, most detailed image humanity has ever seen of this distant planet. Hidden within that image are clues that challenge long-held assumptions. What once existed only in speculation now stands on the threshold of possibility. Proxima b was discovered in 2016. It orbits Proxima Centauri, the closest star to our Sun. With a mass nearly 1.17 times that of Earth, it belongs to the rare category of rocky, Earth-sized exoplanets. And it sits inside the habitable zone, where liquid water could exist. Yet its parent star is volatile, violently active, unpredictably explosive. It unleashes deadly radiation storms capable of stripping atmospheres bare, turning any unprotected surface into a scorched, radioactive wasteland. For years, such conditions made life seem impossible. But uncertainty lingered. Scientists asked, could Proxima b have a magnetic field strong enough to shield life? Could clouds, oceans, or layers of dense atmosphere protect it from stellar fury? Could life survive underground, beneath rock and ice, beyond the reach of deadly flares? For nearly a decade, no one knew. Proxima b remained a cosmic question mark. And then, in early 2025, everything changed. Humanity's greatest eye, the James Webb Space Telescope, turned its golden mirrors toward Proxima b. For the first time, an instrument capable of deciphering atmospheres and heat signatures observed it directly. What Webb revealed was not a blur. Not an indistinguishable glow. But structure. Detail. Coherence. A world with secrets written in thermal light. Webb's infrared instruments, NIRCam and MIRI, captured multiple layers of the planet's emissions. They charted temperature patterns across its surface. They analyzed the chemical composition of its thin atmosphere. And they produced the first direct thermal image of Proxima b ever recorded. The spectral data shocked researchers. Carbon dioxide appeared in measurable levels. Water vapor signatures emerged. An unusual methane signal rose above the baseline. Alone, these gases prove nothing. Together, they form a rare chemical combination. A combination nature rarely assembles without biological influence. But the true shock came from the night side of the planet. The hemisphere forever locked away from starlight. There, Webb detected a faint, steady illumination. A glow too organized to be natural. It did not flicker like lava flows. It did not drift like thermal currents. It did not resemble atmospheric reflections or storms. It appeared rhythmic, precise, geometric. Scientists enhanced the data, filtered noise, mapped the infrared distribution, and the patterns grew clearer. Clusters of illumination, linear formations, geometric shapes. Arrangements nature rarely creates on its own. 3 possible explanations emerged. Atmospheric circulation, winds carrying heat across the dark side. Possible, but not supported by climate models. Volcanic activity, deep magma flows heating the surface. But the glow was too steady and uniform. Too deliberate. Too controlled. Which left the most provocative theory, artificial origin. Could these lights be technological? Could they be energy grids, thermal structures, or cities glowing in eternal night? Could Proxima b host a civilization adapted to perpetual darkness? Humanity had no answers, only questions. Life on such a world would need to be extreme, radiation-resistant, heat-dependent, subterranean or shielded. Yet Earth proves life can thrive in unimaginable places. Microbes flourish in nuclear reactors. Creatures survive kilometers underground. Ecosystems thrive around volcanic vents without a single photon of sunlight. If life adapts on Earth, why not on Proxima b? Why not a civilization built beneath a dark sky? Why not cities illuminated by artificial light across a frozen hemisphere? By the time Webb's image became public, the world was no longer calm. Headlines exploded across continents. Telescopes were redirected. Humanity reacts, technology advances, a new cosmic era begins. When the illumination on Proxima b reached the public, a global wave of fascination followed. News outlets published breathtaking headlines. Possible artificial light detected on Proxima b. Scientists baffled by patterns on nearby exoplanet. A nearby civilization only 4 light-years away. SETI immediately realigned its radio telescopes toward Proxima Centauri. Listening. Waiting. Hoping for even the faintest whisper of a technological signal. Meanwhile, the breakthrough Starshot program revived its ambitious mission. Laser-driven microprobes, chip-sized spacecraft, could be accelerated to 20% the speed of light, reaching the Proxima system in just over 20 years. For the first time, visiting another star was not science fiction. It was a plan. NASA and ESA began preparing additional observation campaigns. More infrared passes. More spectral analysis. More attempts to confirm the mysterious glow. And the world watched. Artists imagined luminous alien cities stretching across a frozen world. Writers envisioned civilizations thriving in endless night. Filmmakers rewrote scenes of first contact and cosmic wonder. Philosophers debated the meaning of sharing a universe with another intelligence. Even children asked the simplest yet deepest question. Are they looking at us too? If the glow was natural, it would still be extraordinary. A new understanding of atmospheric physics. A new chapter in planetary science. But if the glow was artificial, everything change. Biology change. Technology change. History change. Humanity change. The night sky would no longer be silent. It would no longer be empty. It would no longer be ours alone. New instruments promised clearer answers. The extremely large telescope in Chile, near a 40-meter mirror, would surpass all ground-based telescopes in power. Its adaptive optics could erase atmospheric distortion and reveal planetary atmospheres with staggering clarity. NASA's Nancy Grace Roman telescope would survey entire planetary systems, tracking how their atmospheres evolve, identifying targets for direct imaging, helping confirm Webb's discoveries. And beyond them lies LUVOIR. A future observatory so powerful it could image continents, oceans, and weather systems on distant Earth-like worlds. It might detect artificial illumination with precision. It might reveal alien coastlines or cloud patterns. It might provide the first undeniable portrait of life beyond Earth. Starshade technologies, massive, flower-shaped optical masks, could block starlight completely, allowing telescopes to photograph exoplanets with perfect clarity, revealing surface detail unimaginable today. Humanity stands on the edge of an epoch-defining discovery. A revelation capable of rewriting evolution, philosophy, and existence itself. Proxima b is no longer just a distant world. It is a cosmic question. A possibility. A mirror reflecting our hopes and fears. A faint glow across deep space. A whisper from a world we cannot yet understand. A reminder that we may not be alone in this vast, ancient universe. Webb gave us more than data. It gave us wonder. It gave us courage. It gave us perspective. Now, when we gaze at the night sky, we no longer ask, what are those lights? We ask, who might be behind them? The universe has grown larger, deeper, stranger, and far more alive than we once believed. We are no longer simply observers of the stars. We are participants in a cosmic dialogue. And perhaps, someone, somewhere, is looking back.